Good morning, students. What are seen in the previous class? In the previous class, we had discussed some exercise example problems and then Doppler effect. What is Doppler effect and what are the possibilities for Doppler effect and what are the conditions for no Doppler effect and how to express the apparent frequency due to Doppler effect, and then some example problems also all are discussed in the previous session. Okay, in the today's session we will solve the some exercise problems. In our book back 7 exercise problems are there, and then very brief having 2 problems. Okay, so I explain one by one. Okay, first enter this topic. First all of you take your classwork note and all of you note down all the steps to be involved in each problems. Okay, and note down the formulas also. Okay, first you have to note down the formulas. Velocity v is equal to n into lambda. N into lambda means n is frequency and lambda is wavelength. So velocity of the sound v is equal to product of frequency and wavelength of sound wave. Okay, so v into lambda, and then velocity v is equal to distance by time. Already you know that velocity v is equal to rate of change of distance by time, that d by t. And third one is time period of one revolution, or time period is equal to reciprocal of frequency. T is equal to 1 by n, reciprocal of frequency. And in the radar method or in the sonar method, time distance d is equal to c into t by 2. That is, c is velocity of sound 334 or 340 meter per second, and t is time and by 2. And fifth one, velocity at a particular time is equal to velocity in initial time plus 0.61 into time, particular first time. Initial time, that is t, v is initial initial velocity of the sound, and not initial time, that is the temperature. Every degree rise in temperature, the velocity of the sound 0.61 times to be increases. This is the formula for velocity of, easily find out, this is the formula it will be used to find out the velocity of the sound in a particular temperature. Okay, so Vt is equal to V0 plus 0.61 into T. Okay, first I will read the first problem. Okay, a sound wave has a frequency of 200 Hz and a speed of 400 meter per second in a medium. Find the wavelength of the sound wave. A sound wave, okay, has a frequency 200 Hz and a speed of 400 meter per second. Find out the wavelength of the sound wave. Okay, wavelength. So we want to first we have to mention the given values. The given first problem in given values. What is the given values? Velocity v is equal to 400 meter per second. Okay, 400 meter per second, and then other than that, frequency n is equal to 200 Hz. So we want to find out the wavelength of the sound signal. What's the formula it will be used to solve this problem? This is the formula. V is equal to n into lambda. So solution, V is equal to n into lambda. We want lambda, so V by n, velocity by frequency. Substitute the velocity value, substitute the frequency value. Velocity value is 400 and frequency value is 200. 0 cancel, 1 2s are 2, 2 2s are 4. So lambda 2 is equal to 2 meter. Okay, 2 meter. Okay, this is the wavelength of the sound signal, sound wave. So frequency value it will be given, velocity value it will be given. So we have to take the formula and put the value for velocity and the frequency, easily find out the wavelength. Okay, this is the first problem. And second problem is, the thunder of cloud is heard 9.8 seconds later than the flash of lightning. If the speed of sound in air is 330 meter per second, what will be the height of the cloud? The thunder, okay, we hear 9.8 seconds. We hear 9.8 second later than the flash of lightning. Lightning kapra sound 9.8 sound later we hear. Okay, so if the speed of the sound in air is 330 meter per second, what will be the height of the cloud? We have to calculate the height of the cloud. So we want to calculate the distance of the cloud from the ground. Okay, so first what are the given values na? Second problem, time t is equal to 9.8 second, and then velocity of the sound c is equal to 330 meter per second. Okay, we want to calculate the height of the cloud from the ground. So h value we want to calculate. H it will be taken as d. Okay, so h it will be mentioned with the d. So easily find out the solution is distance. Actually velocity v is equal to distance by time. Velocity v is equal to distance by time. In this problem velocity will be mentioned with the c, and d is mentioned with the height of the cloud and time. Okay, c is equal to h by t. We want height of the cloud only, so h is equal to c into t. Substitute the c value and substitute the t value. C value is 330 and t value is 9.8. So 330 into 9.8 is 3234. 3234 meter. Okay, so this is the second problem. It's a easy problems. Velocity v is equal to rate of change of distance by time, so d by t. D we have to consider as height of the cloud from the ground, so c is equal to h by t. H is equal to c into t. Substitute c value is 330 meter per second. 330 into time is 9.8. So 330 into 9.8 multiply 3234 meter. Okay, this is the value for height of the cloud from the ground. It will be reasoning for the lightning or thundering, and thundering. Okay, and third problem, a person who is sitting at a distance of 400 meter from a source of sound. A person who is sitting at a distance 400 meter from the source. Okay, one person will be sitting away from the source, that is 400 meter. Sound is listening to the source of sound is listening to a sound of 600 Hz. The frequency is 600 Hz. Find out the time period between the successive compression from the source. So we want to calculate the time period. The distance value do not need to calculate the time period. Okay, simply we easily calculate the time period value by the use of frequency. So third problem, the distance value it will be given. Distance d is equal to 400 meter, and frequency value it will be given. Frequency is equal to 600 Hz. Hz is Hz. And what will we find out? Time period will be, we want to find out. Time period is equal to question mark. Solution. What's the formula it will be used to solve this problem? This is the formula. Time period is equal to reciprocal of frequency. So time period is equal to reciprocal of frequency. Substitute the frequency value. So 1 by 600. 1 by 600. 600 it will be mentioned with 600. 1 by 600 value is 0.0017 second. 0.0017. 1 by 600. So 1 by 600 we easily find out 1 by 6 into 10 square. Okay, so 1 by 6 into 10 power minus 2. Okay, 1 by 6 and into 10 power minus 2, that is 0.0017 second. That will be rounded off 0.002 seconds. So 177, the above 5. So 1 it will be increases for the previous term, that is 0.02 seconds. So this is the answer for the third problem. Okay, frequency value it will be given. Is easily find out the time period. Time period is the reciprocal of frequency. Clear? So this is the third problem, and then we want to calculate the fourth problem. An ultrasonic wave is sent from the ship towards to the bottom of the sea. Ultrasonic wave is sent from the ship towards to the bottom of the sea. Okay, bottom of the sea, and okay, or ultrasonic wave it will be travel. It is found that the time interval between the transmission of reception of the wave is 1.6 seconds. The time interval between the transmission and reception, that it will be 1.6 second. That is, ultrasonic waves it will be transmit to the sonar to bottom of the sea, and it will be received from the sonar also. So transmission and reception time, that is 1.6 second. What is the depth of the sea? Again the D value it will be calculated. What is the depth of the sea? Its velocity of the sound in the sea water is 1400 meter per second. The sound it will be travel in a sea water, that the speed is 1400 meter per second. So first you have to write down the given values. So first one, the time, fourth problem, time t is equal to 1.6 second. Okay, time t is equal to 1.6 second. Velocity of sound in sea water, c is equal to 1400 meter per second. In sonar, we want to calculate the depth of the sea. Depth of the sea, we want to calculate depth of the sea. So D is equal to question mark. So solution is 2 times the sound it will be travel. Okay. So D is equal to CT by 2. So the time it will be calculated for transmission and then reception. So it will be taken as 2. T by 2. T it will be taken as T by 2 because 2 times in the sound it will be travel, the time it will be calculated in 2 times also. So CT by 2. We want D. So substitute C value and T value. C value is 1400, T is 1.6 by 2. So 1 2s are 2 and 0.8. Okay, 0.8 2s are 1.6. So 1400 into 0.8, that is 1120 meter. 1120 meter. Okay. So the height of the sea. The what's the question is? What is the depth of the sea is the question. So the depth of the sea from the ship 1120 meter. Okay. So easily find out C value is given and T value is given, is easily find out the D value. What's the D value? The depth of the sea. Time it will be taken as half of the time interval between the transmission and then reception, because the signal will be goes from the sonar and then signal it will be fall on to the particular thing in a sea, that the signal it will be again it will be retrace their path and it will be received from the receiver in the sonar. So transmission and reception 2 times, so the time it will be taken as half, so CT by 2, so 1400 into substitute the C value, T value, and we easily find out the D value. D value is the depth of the sea, that the value is 1120 meter. Clear? And then go for the 5th problem. A man is standing from the 2 vertical walls. A man is standing between the 2 vertical walls. Between the 2 vertical walls. Okay. 680 meter apart. 680 meter apart. Okay. He claps his sounds and hears 2 distinct echoes after 0.9 second. He claps his sounds, claps his hands to create the sound. That the sounds it will be retraced and then create echoes after that. The echoes it will be heard by the person after 0.9 seconds and 1.1 second, because 2 sounds it will be created. And what is the speed of the sound in air? We want to calculate the speed of the sound in air. So first 2 distinct echo time it will be given. So first we want to calculate the time. 5th problem. So first time T1 is equal to 0.9 second. T2 is equal to T1 is equal to 0.9 second. T2 is equal to 1.1 second. 1.1 second. Okay. Then we want to calculate common T value, time interval T value. So T is equal to T1 plus T2. The average time T is equal to T1 plus T2. So 0.9 plus 1.1, that is 1.0 second. Sorry, 0.9 plus 1.1, 2.0 second. Okay, 1.9 plus 0.1, that is 2.0 second. Then this is the time, and then we calculate the, so another one value is given. Distance D is equal to 680 meter apart. Okay, so we want to calculate the velocity of the sound, speed of the sound. So how will you calculate? What's the formula for speed? What's the formula it will be used to calculate the speed of the sound? D is equal to Ct by 2. This is the C value, this is the D value, this is the T value, 2 value. This is the formula for this question. This is the formula for this question. Yes. So the distance in D is equal to distance by time. So C is equal to D is equal to Ct by 2. We want C only. So C is equal to 2 into D by T. Substitute the D value, substitute the T value. What is D value? 680. So 2 into 680 by T value is 2. 2 to cancel. 2D by T. So 2 to cancel, balance 680 meter per second. So that's the speed. That's the value for speed of the sound. It will be travels in an air is in between the two vertical walls. Okay. So okay. Then sixth problem. Two observers are stationed in two bodies. In two boats 4.5 km apart. Two observers are stationed in two boats. Okay, two observers in two boats. The two boats distance is 4.5 km apart. A sound signal sent by one underwater. Sound signal it will be sent by created by a first person under the water reaches the other after 3 seconds. Two person. Okay, it will be rest position in the two boats. The in distance between the two boats is 4.5 kilometer. Okay, one person will be create one sound under the sea water. That the sound it will be travels under the sea water. That the sound it will be received by the another one person after 3 seconds. What is the speed of the sound in water? This is the question. So what are the given values, ma? There's a given value is distance D is equal to. Given values are distance D is equal to distance value it will be given. Okay, 4.5 kilometer. Okay, 4.5 kilometer. Then kilometer it will be converted into meter. Okay, 4.5 kilometer, that's 4.5 into 10 cube meter. Okay, kilo is equal to 10 power 3. Then distance value it will be given and time value it will be given. Time is equal to 3 seconds. What will we find out, ma? That is the speed of the sound we want to find out. So speed of the sound C is equal to question mark. So we what's the formula it will be used in this problem? Solution. Speed of the sound C is equal to rate of change of distance by time. D by T. So D 4.5 into 10 power 3 by time is 3 seconds. Okay, 4.5 into 10 power 3 by 3. 4.5 by 3, that is 1.5. So 1.5 into 10 power 3 seconds. 1.5 into 10 power 3, this is 1500 seconds. So the speed of the sound is 1005. So speed of the sound, that is not a second. So what's the unit for speed? Meter second per minus 1 or meter per second. So the velocity of the sound it will be travels in between the two persons. That the two person it will be stationed in the two boats. So C is equal to 1500 meter per second. That's the speed of the sound. It will be created by the first person. That the sound it will be received by the second person. That sound it will be travels in the water. So the speed of the sound in water is 1500 meter per second. Okay. And what's the seventh problem? A strong sound signal is sent from a ship towards the bottom of the sea. Okay, a strong sound signal is sent from a ship towards the bottom of the sea. Clear? It is received back after 1 second. It is received back after 1 second. What is the depth of the sea is given that the speed of the sound in water. So what's the question? The sound signal it will be sent from a ship towards the signal it will be passed towards the bottom of the sea. The signal it will be received after 1 second. So the time t is equal to 1 second. What is the depth depth of the sea. Question is depth of the sea. D value we want to calculate. D value we want to calculate. But it is received back after 1 second. Received back after 1 second means the sound it will be traveling. One time it will be travel, one time it will be retrace their path and received. So 2 times it will be taken as 1 second. போகிறதுக்கும் அந்த டைம் டிஸ்டன்ஸ் சவுண்ட் ட்ராவல் ஆக அண்ட் தென் ரிசீவ் ஆகிறதுக்கு இந்த ரெண்டுக்குள்ள டைம் தட் இஸ் 1 செகண்ட். ஸோ த சிக்னல் டைம் duration is half second. 1 second it will be mentioned. So the time it will be calculate received back after only. So t is equal to half second. So what is the depth of the sea is given by the speed of the sound in water. The speed of the sound in water is 1450. Okay. So what are the given values? What are the given value in this problem? C values will be given. Velocity of the sound C is equal to 1450 meter per second. 1. And then time t is equal to half second. Time t is equal to half second because it will be received back at 1 second. So transmission of second and reception of second. So we want to calculate the only received signal only. So time t is equal to half second. Okay. And then what is the depth of the sea we want to calculate. So depth D is equal to question mark. What's the formula to use to this problem? Solution. Always velocity C is equal to T by D by T. We want D only. So D is equal to C into T. Substitute the C value, that is 1450 into time is half. So 1 2s are 2, 7 2s are 14, 2 2s are 4, and then 10, 5 2s are 10. So 725 meter. 725 meter. So the depth of the sea is 725 meter. This is the I explained all the 7 example exercise problems. And now I explain the brief question only, very brief question. Third question, what is the minimum distance is needed for an echo? So that is 17.2 meter. And fourth one, what will be the frequency sound having 0.20 meter as its wavelength when it travels with a speed of 331 meter per second? The frequency value we want to find out. Wavelength is 0.20 meter with a speed of 331 meter per second. So what are the given values? Wavelength value will be given and velocity value will be given. What is the wavelength value? Wavelength lambda is equal to 0.20 centimeter. 0.20, not a centimeter, meter ma. So 0.20 meter, and then speed of the sound C is equal to 331 meter per second. This is the very brief fourth one. Okay. 331 meter per second. We want to calculate the frequency. We want to calculate the frequency. Frequency of the sound. So frequency of the sound, already I told the formula for velocity V is equal to n into lambda. So we want to calculate the frequency of the sound. So solution. What's the formula ma? V is equal to n lambda. We want n only. So n is equal to V by lambda. Substitute the V value, that is the V value is C, that is the V. So 331 by lambda value is 0.20. Okay, 0.20. Now we easily calculate 331 by 0.2. So multiplying up and down by 100, 331 by 20. Okay. So easily find out, that is the value is 1655 Hz. Multiplying numerator and denominator by 100. So 33,100 multiplied by 100. 331 is multiplied by 100. 33,100 by 0.20 is multiplied with 100, that is 20. 2 cancel in numerator and denominator. So 3310 by 2, that is 1655 Hz. This is the answer for this question. Okay. And answer brief for third one. Air temperature in the Rajasthan desert and can reach 46 degrees Celsius, what is the velocity of the sound in air at that temperature? So in Rajasthan desert, the temperature is 46 degrees Celsius. What is the velocity of the sound in air at that temperature? Okay, that's a question. So degree Celsius, that's the temperature value. So first we write the given values. First, the temperature is a very brief thought. The temperature is in Rajasthan desert, the temperature is 46 degrees Celsius. Okay, question is the temperature in Rajasthan desert at 46 degrees Celsius. What is this velocity of the sound in air at that temperature? So we want to calculate velocity of sound in air. So we want to first, you should know about what is the speed of the sound. Speed of the sound V0 is equal to 331 meter per second. Okay, the speed of the sound in air V0 is equal to 331 meter per second. So now we want to calculate the velocity of the sound at a particular time is the question mark. In Rajasthan desert, as I am having some degree Celsius, what's the speed of the sound in Rajasthan desert? This is the question. Okay, so velocity of the sound at a particular temperature is equal to question. We want to calculate. So Vt is equal to, what's the formula? The last formula, Vt is equal to V0 plus 0.61 into T. So this is the formula solution. So substitute all the values. Vt is equal to V0 is 331 plus 0.61 into time is 46 degree. Okay, 0.61 into not a time, that is a temperature. So 331 into 0.61 into 46, that is 28.0631. So multiply in 0.61 into 46, that is 28.06, and add the two values, that 359.06 meter per second. So the velocity of the sound in the Rajasthan desert at the 46 degrees Celsius, that is Vt is equal to 359.06 meter per second. So by using this formula, velocity of the sound at a particular temperature is equal to V0 plus 0.61 temperature. So Vt is equal to 331 plus 0.61 into the temperature value is 46 degrees Celsius. So 331 plus multiplying the two values, that is 28.06. So add the two values, the 359.06 meter per second. Okay, this is the answer for the third brief. So in the today's session, I explained 9 problems. In the first problem, velocity value will be given, frequency value given. We easily find out the wavelength value by using the formula V is equal to n into lambda. Okay. Second problem, time value will be given, velocity value will be given. So we want to find out the distance value. Distance d is equal to velocity into time. Substitute the velocity value, substitute the time value, easily find out the distance. And the third problem, frequency value will be given, we easily find out the time period. Time formula is time period t is equal to reciprocal of frequency. T is equal to 1 by n. Substitute the n value, so easily find out the time period. And the fourth problem, t value is given, c value is be given, we want to calculate d value. So d is equal to ct by 2. C value, t value, we have to put, easily find out the d value. D is equal to ct by 2. The answer is 1120 meter. Okay. In the fifth problem, d given, t1 given, t2 given. So first find out the common t value, add the two t1, t2 values and find out the common t value and substitute the t value and d value in the formula of c. C is equal to 2d by t and we get the value is 680 meter per second. In the sixth problem, d value will be given, t value, d and t value was given. So we easily find out the c value. C is equal to d by t. Substitute the d value, substitute the t value and easily find out the c value. Okay, velocity of sound value. And seventh problem, time value will be given, but time will be given for transmission and reception. So total time is 1 second. So we have to consider the half second for reception. So time t is equal to half second, and distance value is we want to find out, and velocity value is 1550 meter per second. So easily find out the depth of the sea. Depth of the sea is equal to 725 meter. And very brief fourth question, wavelength value is given, velocity value it will be given. So easily find out the frequency value. Frequency n is equal to c by lambda. Substitute the c value, substitute the lambda value, easily find out the frequency value. Frequency is equal to 1655 Hz. And then brief answer in brief. For third problem, in Rajasthan's desert having some temperature, that the temperature we want to find out the velocity of the sound. Okay, so the velocity of the sound formula, Vt is equal to V0 plus 0.61 into temperature. So substitute the temperature value, substitute the initial speed of the sound in air value, and then we add the two values, so we easily find out the velocity of the sound. It will be travel in the Rajasthan desert. Okay, this is the all the exercise problems in our 5th lesson. Okay, and then home assignment for today's session. First, copy all the problems. Copy all the problems in your classwork note. Second one, learn the formulas in unit 5. Learn the formulas in unit 5. Copy all the problems in your classwork note and learn the formulas in unit 5. Clear? Thank you.